Alright, 6. Welding requirements control channel with the section contained with the requirements of the controls that are essential ensuring satisfactory weld. The machinery pipe to pressure valve platinum turbines here and are referred to with the MPANT. Gas metal arc welding circuitry transfer the gas metal short arc. Restriction process shall not be used unless otherwise approved, but otherwise for the specification application for the case-to-case basis of the Navy Sea System Command. Non-structural weld of the nameplate clips and the insulation support for the class Pipe 1 and Pipe Limited to AF1, AF, A1, A2, A3, and AF Limited to Turbine 1 and Machinery 1 components shall be made and welders qualified for the butt and fillet weld. These welds shall be inspected for accordance with the section. Aerogenous welding should not be used with the S10H materials welding process filler materials. Simple welding profit comparable to filler materials are shown with the table 3 with the specific filler material with the steam services application should be conformed with the 6251 profit. This material is not listed with the table 3 with the material with the conformed with the 6251 shall be permitted where applicable. The welding procedure qualification data are approved for the Navy Sea System Command. Authorized particular production application of aluminum alloy should be welded only with the inert gas metal arc, inert gas tungsten arc and process with the root passive of the SPH S8 piping welds and reverse side of the weld cannot be visually examined. Exposed the wire should be welded with a gas shield welding process. Near gas welding gas shield is also required with the S51, S52, and S53 materials in the required in 627. Oxyacetylene restrictions. Except for the permitted with 11.6 oxyacetylene fuel gas welding process should not be used with the welding chromium molybdide, molybdonium 7475, chromium alloys 76 and 77, chromium nickel 7 and 8, and quenched tampered alloy steel 711, aluminum alloys S21, 22, S25, and 26. Class P material thickness limitation. Shielded metal arc process may be used with the wall thicknesses up to 109 thousandths of an inch thick or welded on board shipped, and 83 thousandths of an inch or over welded in the shop. Or welding process will be permitted for thinner walls of the basis of welding procedure qualification and test. Covered electrode class P1 carbon steel pipe with the class P pipe 1 carbon steel pipe shall be welded on electrode mills 701B, 701AM, 701AA1, 70 mill S7015, mill 7016, A2A, except for the nominal wall thickness 1/2 inch or less. Mill 7010 A1 electrode A1A may be used. Prohibited electrodes and specialized approved of the military in 6010 with the 6012, 6013 electrodes. The AWS 51 shall not be used for machining, piping, or AA applications. Welding process comparability filter, filler metal wheels base, S group number shield metal submerged gas shielding process with tungsten flux oxygen inserted plasma arc. And this is carbon steel quench tempered alloy steel 3.25% chromium hollow alloy, not 10% helium alloys, arsenic, ferritic, austenitic, column duplex quench tempered alloy steel, aluminum and aluminum base alloys, copper and copper base alloys, nickel base alloys, chromium chromium alloyed hard surfacing titanium and titanium alloys. Alright, 625, selection filler material. Filler material should be selected compatible with the base material of the base chemical for the composition, mechanical properties, post-developed heat treatment requirements, and components to the operating condition requirement of the table 2 and 3. Identifying specification with welding may be found with the system for the selectable compatible filler material with more commonly used the base material. Filler material steam for the application of ferritic air and arsenic steel filler metal with the base material with the commonly used the steam for the application should be as follows. Base material S group number, filler metal A group number, S1 materials A2, AB, A20, A1B, A1A. Mill 7010 A1 is only noted in 62373. Materials A2, military 7010 A1, 7011 A1, 7011, 7018 A1, 7020 A1. SA3 materials A3, AB, and A3B, A3A, A3B, A3C. S4 materials A6A. A6B, AC6C, 7 the S5F materials A6A, A6B, A6C, S6 and S7 materials A72, A7B2, S6A, A7A2, and A7B2. Alright, for welding, different combination base materials are specified in 62511. For the welding filler, metal should be specified with the E without base material involved, except for the covered electrodes on the low hydrogen type. The XX15, 16, and 18 should be U with the SA3A, S4, S5, S6, S7, the base materials. 62513 for joining base materials under the group 7A, S1, S3, S3A, S4, S5, S6, S7. Base materials under subgroup S8. Following filler materials shall be U, the nickel base alloy, the A43A, A43B, high alloy austenitic A88, A88A, A88B. For post-weld heat treatment required with the component of the equipment specification where designed for the temperature for the exceed 400 degrees Fahrenheit, only listed above the A43A with the A43B filler metal should be used. 6251A, for the application resisting steam cutting with the filler material specified in 62513 may be used with the base material of the undergroups S1, S3, S3A, S4, S5, S6, S7. The subsequent post-heat treatment of the base materials required with the mill 8, 9, 12, EN82 and RN82 filler metals should be used. 62F15 for welding dissimilar metal combinations, the S10H and the S11 or S2 alloy steels. Electrode shield metal arc welding of the mill 1 and 12 of the mill E22003. Gas metal arc, gas tungsten arc filler with filler metal materials of the mill EN625 mill RN625 mill East 2156 are applicable. Number of the weld of the passes, unless otherwise approved, not less than 2 layers, shall be used with all pressure containing welded joints, welded backside shielding, inner root surface of all support of the inert type of the weld, with all full preparation, butt weld, and employment of the back ring shall be shielded by insert ring gas, an internal plug of the continue with the after completion of the third layer with the 3/16 of the inch, whichever the degree of the requirement that does not apply with the heat to pipe 2. Type of welding joint and pipe 2 piping system materials of then S21 through S26 provided with the demonstrated the satisfaction of the authorized representative of the internal surface of the welded meets visual requirements of military standard 2035. When welding in or on titanium alloys include repair welding of the base metals and the base metal and the welds, the welding area backside shall be shielded with an air gas unless the backside temperature is determined to remain less than 500 degrees Fahrenheit. Shielding should continue until the completion of the weld with the temporary shell to determine the actual checking actual backside surface during the pair welding parameter of the other suitable mean if they are inaccessible to measurement. The back mock-up of the weld heat sinking simulation worst case production conditions shall be welded. Temperature measurement shall be obtained with the mock-up of the backside area as necessary to demonstrate that the temperature of the weld will remain below 500 degrees during all production weld. The description mock-up of the welding and temperature test results shall be maintained welding procedure qualification records. Age-hardened alloys. Welding age-hardened alloys is subject to the Navy Sea System Command. Preheat interpass and temperature for the preheating interpass temperature shall be specified in the tables 4 through 5 unless they otherwise approve of the welding procedure qualification. Alright, and it says carbon steel, quench tempered steel, chromium alloy, magnesium alloy, nickel magnesium alloy, chromium molybdenum steel, chromium 3/4 to 2%, chromium molybdenum steel greater than chromium 2%. High alloy steel S65, high alloy steel S6A, high alloy steel S7, high alloy austenitic steel S8, S10 high alloy steel duplex stainless steel, and S11 in the notes. S21, 22, and 26 aluminum and aluminum base alloys. S33 silicon bronze, 734 copper nickel. Max temperature 350, 35, minimum temperature aluminum bronze 300, nickel aluminum bronze 36A, 36B magnesium nickel alloy bronze, S37A magnesium bronze 300 degrees Fahrenheit, 37B nickel bronze techno band, 738 10 nickel bronze, 739 bronze phosphorus bronze, 742 nickel copper, 743 nickel chromium and nickel chromium molybdenum cadmium. Maximum 350, so S44 nickel molybdenum chromium alloy 200, S51, 52, F53 titanium and titanium alloys, minimum temperature 600, maximum interpass temperature 250 degrees. Alright, 631. Method of the preheating of an inner path of the temperature control. Preheat may be applied with a method to ensure the uniform temperature of the joint to be welded. Cycling heat serve the air temperature for the gradient of the welded area shall be avoided with the inner path temperature shall be controlled by the proper plate for the preheat elements control of the power unit. Proper welding. Seek for the proper distribution of the weld. Welding operator shoot with the weld wine inclement weather until the weldment of the cool with the ambient temperature plus 50 degrees and left with the pulse weld truss, leaving the wires performed with the intermediate upon with the completion of the welded gas torch frame. As due to the lowering temperature preheating, there will show no condensation in any welding. Any condensation in any way of the welding. Titanium and titanium alloys heating the S51, S52, and S53 materials should be limited to use the lamp resistant heaters induction heating. Use of oxyflame gas torches is prohibited when using resistant heaters induction coil contacting heating elements with the work shall be avoided. Verifying temperature. Preheating inner path temperature shall be verified. Periodic checks use the indicating device for the crayons and electrical pentameters. Use the low metal and metallic alloys temperature measurement. The prohibited crayon markers should be located a minimum 1 inch away from the weld area. Temperature indicating crayons should not be used with S51, S52, S53 material. For the material temperature will be measured within the contact pyrometer. Post-heating, unless otherwise authorized, approved the post-heating weld to joint the relief strength and improve the metallurgic corrosion-resistant properties. All heating affected zones should be performed in accordance with Table 6 of the ferrous alloy materials, Section 8 and 641 and through 646 of the non-ferrous alloys. For the dissimilar thickness of the post-weld heat treatment shall be passed over the thicker member, hold time, and the temperature shall be passed for the weld metal thickness, including reinforcement. Show the table 6 show the post-heat requirement of the weld ferrous materials. Show the material identification, group number, identification 1, hold temperatures 2 and 3, machining M pressure vessel turbines AF, AL, T, A1, A2, A3, A4, T1, 2, 3, piping class. And then it goes through all the metals. It's just like 53, no. And then these are the notes. Alright, 6.4. Nickel alloys post-welded treatment. The following non-ferrous alloys should be performed and left the necessary of the dimension stability, in which case the temperature shall be the indicated nickel copy on alloys. See the note 1 in Howard per inch thickness or thicknesses. Chrome, copper, nickel alloy, 5575 to plus or minus 25 degrees temperature, less than 1 inch holding time, which should be. Nickel chromium iron, 743 S43. See note proportional, not less than 30 minutes. Weldments to be post-weld heat treated should contain with a weld deposit made with electrode type of 3N10 with 8N10 mil E22 203 with the electrode type of the E nickel chromium malide 4 ER nickel chromium malide 4 AWS A511 through N514 respectively. Precipitation hardened nickel with weldment should be struck with the relief of the heat of a copper nickel alloy welded with the copper nickel with the nickel copper filler. Materials may be struck with the relief of the heat treat with the dimension stability subject to the prohibitions again with the type 3N 10 and 8N10 electrodes holding temperature for the S42 for the 43 materials shall require with the Navy SEAL system command appropriate prior to the performance of any post-weld heat treatment. The responsible for the activity should be recommended with the desired holding temperature and shall provide sufficient technical information to demonstrate that the required mechanical properties will be maintained. 642 aluminum alloys post-weld heat treatment shall not be performed on wrought aluminum alloys. Aluminum alloys do not specify cover the possible post-weld heat treatments for the alloys not covered the document shall be considered the approval of the basis for the qualification test which shows such post-weld heat treatment is essential for the element of the welding procedure. Age hardening alloys with a specific age heating treatment cannot be performed while filler metals are reviewed that don't respond to the age heating treatment. The design review shall be performed and ensure the welding satisfied with the design requirement of the Navy SEAL system command. Navy Sea system command approval of the repair shall be obtained. Alright, copper alloys. In general, the copper alloy casting does not require post-weld heat treatment to improve the corrosion resist exemption for this nickel alloy browns at the corners of the mill B24480. Post-weld temperature anal heat treatment is required with the weld is made with only as any surface exposed with sweet sea water where heat affected zone extended to within 1/4 inch of the surface. The post-weld heat treatment is not required with the non-sea water application when the required temperature annealing shall consist of holding the case to casting in 1250 plus or minus 25 degrees for a 6-hour minimum followed by air cooling. Alright, 646 titanium and titanium alloy. General heating requirements. The furnace equipment requirement that heating proceed with the minimum metal removal after the exposure to the high temperature. General information referred to mill H81200. Stress relieving when required. The dimensional stability S51 and F252 materials should be stress relative to the temperature greater. Relieve the stress relieve the temperature ranging from 900 to 1100 degrees Fahrenheit for 1¼ hours per inch, which with a range of 1¼ to 4 hours. 753 materials shall be stress relieve the temperature ranging from 900 to 1200 degrees Fahrenheit for 1 hour per inch, with a range of 1 to 4 hours. Annealing when required to improve the ductile dimension, thermal stability with fractional toughness. Creep resistant S51 and S52 materials shall be annealed with a temperature ranging from 1200 to 1400 degrees for 1¼ hours per inch, which ranges from 1/3 to 2 hours. The S53 material should be annealed with a temperature ranging from 1275 to 1500 Fahrenheit for 1 inch per hour, which range from 1/3 to 2 hours. For special requirements for welding, forming the S11 steel with the special and treatment steels. Welding will form with the HYAHSLA steels with the STS steel shall be in accordance with the mill standard 1681, 1688, steel 1689 is applicable with a preheat interface the temperature filters, metal section, post weed, temperature of the holding time, mill S23, 28, 4, steel shield. Steel shall conform with the requirements of mill standard 2191. Welding procedure qualification shall employ mill S 2328-4 stainless steel unless otherwise approved with the Navy SEAL System Command. Special requirements of the welding mill 120-140 series filler material except the mill standard 2191 application for the handling storage mill 12018 electrodes. Additional requirements shall be approved with the Navy SEAL System Command. Welding military 120-140 series filler material. These are additional requirements that involve at least the following items. Heat input minimum maximum requirement of the heat soak requirement of the weld repairs as required preheat interpath temperature minimum and maximum requirement of the loss of the preheat heat soak with the weld removal that requires ordering temp requirements and the recip. Inspection of the welder filler material, the welder repeal of the base material, welder repeal of undermatched filler material, lube of the mill 120-140 series of the filler miller materials. Electrode handling and storage, general welding electrode, and crew to cover the type of the bare spool with electrode wire form handle to prevent the damage of the wear. Containers show evidence of the damage of their content to be examined. The electrodes with cracked and flacked off coatings. Damaged spool of the filter metal should not be used for the production weld. And covered electrode and bare electrode wire form and rods will be stored under the clean dry condition to prevent damage from the contamination moisture of the water. 661 covered electrode mill type 9 18 118 111 18 12018 118 N1 4010 nickel molybdenum. Low hydrogen types include ferritic and austenitic non-ferrous alloy types except for the mill types 9 18 118 110 18 112 18 118 N1 and 4110 nickel molybdenum or similar ASW ASTM types. The C662 should be used within 9 hours after the removal of the hermetically sealed containers of the holding oven. The holding oven shall be vented type and temperature of the 150 to 350 gears should be maintained. Electrodes exposed to the ambient conditions for more than 9 hours after removal should be held for at least 8 hours of 150 to 350 degrees Fahrenheit and vented oven prior to reissue. Our conditional electrode mill type 9010 9890 10 18 1000 118 111 18 12 18 118 N1 410 nickel molybdenum type E2109 15 16 electrode mill type 9 18 118 1100 18 110 18 12 18 118 N1 410 nickel molybdenum type E2209 15 16 should do it. Addition in accordance with the 662 and 6624. Are exposed with the electrodes. The electrodes removed with the holding oven and hermetically sealed containers should not be used after they are exposed with the atmosphere for more than 5 hours. Electrodes having exposed with more than 5 hours should be stored with the holding oven or at least 8 hours and baked. And according with the 6623 and electrodes which remove the moisture resistant requirements specified. Mill E222009 may be used with a period of 9 hours without baking. 662 storage and holding oven electrodes should be stored with the holding oven openly hermetically sealed containers. Electrode which have been baked transfer of the holding oven before cooling to 150 degrees. Then temperature should hold in the oven and should be 225 to 300 degrees. Baking electrodes should be conditioned for the baking at a temperature of the 800 to plus or minus 50 degrees, 625 plus or minus 25 degrees, metal 410, and nickel ammonium XX for 1/2 to 1 hour in a forced convection circulation oven. Oven temperature of the type of loading should not exceed 300 degrees Fahrenheit. Electrodes should not spread with a thin layer. Electrodes should not be spread in thin layers of the trays during baking. Temperature should not be raised more than 300 degrees for each hour when over the temperature of the over or 500 degrees or above. Oven should be automatically controlled with the calibration should be checked periodically. Intervals not more than 6 months. Rebaking electrodes is permitted to provide test and perform LH for electrode brand to conform with the number of the rebaking cycle to leave the adversely effective of the weld to deposit the quality in accordance with the governing specification requirements. Moisture check of electrode coatings at the job site is not required. Submerged arc, granular flux, or general welding. Storage granular flux should be stored in a dry area. Reuse, except for the specified in 664, use unfused granular flux may be reused as subject to the following conditions. Flux should be collected from a clean and dry workpiece. Flux should be mixed with the new flux. Submerged arc general granular flux for the welding high hardened alloys. Penetration for use prior to the start of any welding operation. Granular flux should be achieved with a 250 degrees medium while warm. The top of the flux should be achieved in clean, uncoated metal containers. Requirement of flux for SA10 and S11C. S11A and S11C. Material should be in conformity with the military standard 1689. Military standard 1688 is applicable to reuse. The unfused granular flux may be reused subject to the following condition. Flux should be collected from the clean or dry workpiece. Flux should be mixed with approximately 50% new flux. Flux is not warm to the touch and should be reheated to 250 degrees minimum. Titanium and titanium alloyed electrodes, bare spool electrodes, bare rod electrodes should be kept in their original sealed containers until the use to prevent contamination. Wire rods should be handled only with clean fabric gloves, except the leather may be used with the actual welding once running on the wire spool. The titanium wire should be kept unclosed with the dust cover. The wire feed patch should be cleaned at least once daily to remove the accumulated chips of the dirt and the guide tube of the roller with the touch. Manually fed wire rod and shipped wipe shall be wiped with a clean solvent soaked cloth before therefore after handling only with the clean gloves. Wire and rod should always have 1 inch of filler length removed with the top of the tip before reuse. Wire rod does not use the extent of the period shall after removal be contaminated. Stub the end placed in a clean dust-free container. Prior to reuse of the wire or rod electrode should be wiped tested by drawing a clean lint-free cloth wet with solvent along the 12-inch length of the electrode. A slight darkening or smudge in the cloth unacceptable, but any evidence of the foreign material coming off the electrode is causing rejection until the wire is double wiped with solvent respooled and passed for the wipe test. Production tests for the S51, S52, and S53 wells are C40 in the Appendix A and 7 workmanship requirements.